In this video, we're going to look at how to solve this integration problem. First, we noticed we need to integrate a natural log function. We can calculate the derivative of natural log pretty easily because the natural log of x is going to be 1 over x. Therefore, we know the integral of 1 over x dx is going to be natural log of x. However, in this case, we are integrating the natural log instead of 1 over x. Therefore, it's a little bit tricky than just directly using the equation. In this question, we're going to use a technique called integration by parts. Integration by parts is essentially taking the original function and break it into two different functions that's easier to integrate. And the general equation for this is the integral of, let me write it in a different color, the integral of u dv. So u and v are two different functions. It's going to be equal to u times v minus the integral of v du. For this question, let's set our u to be ln of x plus 1. Our dv here is going to be dx. Then we will get du, which is a calculated value, is the derivative of u, which we will get 1 over x plus 1. Here we have dv equals dx. So our v, when we take the integral of dv and integral of dx, our v is going to be equal to x. Now we have all the components we need, which is u, du, dv, and v. We're going to plug in these components into our original equation. Let me show you how to do that. So in here, we would have the integral of natural log x plus 1, which is going to be equal to u times v, which is going to be ln of x plus 1 times v, which is equal to x times x, minus the integral of v times du. The integral of v, which is x, times du, which is 1 over x plus 1. Here I forgot the dx, and here we have a dx as well. So in here we have dx, which we're taking the integral respect to x. Okay, so the front part, we don't have to worry about it. It's a product of these functions. So let's look at the integral of this. For this integral, we're going to simplify it or rewrite it in a slightly different format. And we'll see how that really helps us to solve this problem. So let's write it as the integral of 1 minus 1 over x plus 1. So we know these two fractions are equal to each other. But we look at the right side, which is a lot easier to integrate. On the right side, we have the integral of 1, which is give us x, then minus the integral of 1 over x plus 1, that give us ln of x plus 1. Okay, so let's plug into our original function. We would have ln of x plus 1 times x minus ln of x plus 1. Because in here we have a definite integral, 0 and 1. So first step, let's plug in x is equal to 1. We would get ln of 2 times 1, which is just 1, then minus 1 minus ln of 2. Let me erase this part. So this is when x is equal to 1. Then we need to minus everything when we plug in x equal to 0, which is ln of 1 times 0, which give us 0. So let me just erase that. We have 0 minus 0 minus ln of 1, which we know ln of 1 is also 0. So inside the whole parentheses here, when we plug in x equal to 0, we got 0. So we can erase the second part of the function. Then we simplify our function. We would get 2 times ln of 2 minus 1. And that is answer for this question.